Okay, so let's look at the mechanism behind an ester with lithium aluminum hydride. So we all know that the amount of reaction with esters are really minimum. So we must break through them for compounds which we know, something like alcohols, so those stuff. So this actually plays a major role in that case. And also now you can see that aldehydes, ketones, whatever thing with double bond oxygen with a carbon, we can easily convert it to their respective alcohols. So the mechanism behind that is the thing you should remember is when you compare aluminium and hydrogen, the hydrogen's electronegativity is greater than him. So the partial negative charge is present on to him and partial positive is present on the aluminium. Okay. So if I just start with this, you are having CH3 carbon double bond oxygen OCH3. So that ALH4 minus, you can see that oxygen is more electronegative than carbon. Oxygen is more electronegative than carbon. So this has a very low positive charge. So a very high positive charge, partial positive charge. So since this has a partial negative charge, the hydrogen breaks onto this carbon and this starts to break on. So we will be having the product CH3 carbon and O minus and then hydrogen attached to here and OCH3. And we also know that this is done in an acidic medium. So soon as possible, this binds on with a hydrogen part. That O minus captures a proton. And then you should understand the mechanism process. This used to break onto here, causing the bond to break over to this. So we'll be having the product CH3 carbon double bond oxygen and a hydrogen and O minus and a CH3. Now this O minus and CH3 also the same stuff. It obtains a proton and becomes CH3OH. But you can see still there's an aldehyde. So aldehydes are also capable of reacting with lithium aluminum hydride and sodium bromohydride. So we are having CH3 carbon double bond oxygen and a hydrogen. We can see that again the hydrogen is more electronegative. So he's going to approach this compound again. So this strikes onto here, causing the bond to break over here, which will eventually produce you CH3 carbon, a hydrogen and another hydrogen and an O minus. And we know that with an existing proton, this O minus adapts that. So eventually CH3 carbon, hydrogen, hydrogen, OH is produced. So the thing you should note down in here is the hydrogens which are substituted onto here are mainly done by this ALH4. So whenever they are with ALD4, we'll be having deuteriums attached onto them. And this hydrogen is ensured by the acidity we are making ensure here. So if you are having D plus 2O here, we will be having OD then. So you should understand that difference. The hydrogen attached to the carbon are mainly from ALH4 and the hydrogen attached to the oxygen part in the final alcohol is mainly from the acidic nature. So if it is H plus, it's going to be an OH. If it is D plus, you'll be having an OD, right?